This video, we're going to prove the following fact. For any positive integer n, the summation of sigma of d over all divisors of n is equal to n over d times the summation of n over d times tau of d over all divisors of n. If you like seeing mathematical proofs, you should definitely subscribe to my channel, as this is what we do on this channel. Okay, so let's say since sigma and tau are both multiplicative functions. I proved that in earlier videos. Both multiplicative function. It suffices to verify their statement or the theorem, the above theorem, with n is equal to p to the k. Because every n can be written as a product of primes in this form, and since sigma is multiplicative, if it works for just n equal p of k, it'll work for n equals p of a product of primes, where each prime is raised to some power. Okay. So basically what we want to show is that the summation of, as we sum over all divisors of p to k of sigma of d, is equal to the summation of all divisors over p to the k of this up here. But this summation is over d. N has nothing to do with p, and in our case n has nothing to do with d. In our case, n is p to the k, which I could factor out, times tau of d over d. This is what I want to show. Okay, so maybe if I can, I'll move this, but I can't. Just wanted to write it on the side somewhere. Let's try it one more time. Yep. So this is what I want to show. This here. Okay. So the summation of sigma of d over all divisors of d, of all divisors of, p to the k, well, this is going to equal to sigma of 1 plus sigma of p plus sigma of p squared, all the way up to sigma of p to the k. These are all the divisors of p to the k. This sigma of 1 has one divisor, the number 1. Sigma of p has two divisors, 1 and p. So 1 plus p. Sigma of p squared has three divisors, 1 p and p squared. So sigma of p will be their sum, all the way down to sigma of p to the k. That has 1 and p squared, all the way up to p to the k as its divisors. So sigma of it will be 1 plus p squared plus p cubed, all the way up to p to the k. The second term has p to the 1. So how many 1's do we have? Well, let's count from here. Start from here. 1, 2, notice 1. That's the second time we have 1. This is the kth time we have 1, plus the 1 in the beginning. So we have 1 plus 1, k plus 1 times. And we have p in every one of them except the first term. So we're going to have p plus p k times, all the way down to p to the k that only appears one time. So what we have is the following. We have k plus 1 plus p times k plus p squared times k minus 1 plus p cubed times k minus 2. Notice that the power of p plus this is always k plus 1. K minus 1 plus 2 is k minus 1. If you like, here we have 0, and 0 plus k plus 1 is k plus 1. So when we get down to p to the k, we should just have 1. Okay. Now, let us write this in reverse order. I'm going to write it that way. So we have p to the k plus 2 times p to the k minus 1 plus 3 times p to the k minus 2. Notice that they add up to k plus 1. So all the way down to p to the 1 times k plus k plus 1. Now, if we look at what we want, we just wrote down this. We wrote down this. And we want it to equal the right-hand side. But notice that p to the k is factored out. Okay, so I'll factor out a p to the k. Factor out p to the k, we get 1 plus 2 over p plus 3 over p squared. All the way down to k over p to the k minus 1 plus k plus 1 over p to the k. Now we have p to the k. Now, what do we want? We want tau of d over d. Well, first thing I'll notice is that the 1 is 1 over 1. So tau of 1 is 1 over 1 plus p. Well, you know what? Tau of p is 2 plus p squared on the bottom, and check that out. Tau of p squared is 3. Plus, the bottom isn't going to change, but you know what? K is the same as tau of p to the k minus 1 plus p to the k on the bottom, and tau of p to the k is k plus 1. So what we have is p to the k in the front times what's in the brackets. But what's in the brackets is we have t of d over d, because d, well, let me just say we're going to sum up over all divisors of n, which is p to the k. Well, these are all the divisors. Okay, so it matches perfectly with the bottom, and whatever's in the bottom is what we're taking t of. P, t of p. P squared, I should say tau of p squared. P to the k minus 1, tau of p to the k minus 1. This is just what we wanted to show. We're done. If you like seeing math proofs like this, you should certainly consider subscribing to my channel, as this is all we do here. We do mathematical proofs. Click the like button. Please leave a comment. Once again, subscribe to my channel. See you guys in the next video. Don't forget, watch and learn.